Okay. Let's try this. I'll begin in a couple of minutes and go through the lecture. The lecture today is three pages. Mainly the difficulty is grasping the concept as a limit approach. So, not limit approach, figuring out the limit as our x for approach. So anyway, a minute. Okay. Okay, two fundamental ideals two fundamental ideas in calculus. Page. Okay. So our first fundamental idea is the tangent line. And the tangent line is the thing we covered yesterday. It's so the first one is the tangent line, and that is another word slope or either slope or you can say derivative. Okay, slope or derivative. That's our first idea. Our second idea is finding solving the area of the curve. So the area should be of a region. Okay. Solve the area of the region. So for finding the area of the region. Blow that up so it's clear. So equal. Okay. So solve either the tangent line or derivative. And this one again is just limit as x approaches as h approaches 0, f of x plus h minus f of x divided by h. So that's the limit. And what we're going to find here is that this one's actually going to be about infinity. Okay? So we'll talk about this next class. Okay. We talked about horizontal asymptotes before, and how we approach. We're getting closer to the number, but we never really reached that number. We just get closer and closer and closer. So if f is a function and we have some L 1, so limit 1 and limit 2 are real numbers. Okay. So that be the limit? Oh, hi, Annie. Hi, Annie. Okay, the statements. What are the statements that we're looking at? So the statements, the limit as x approaches negative infinity. Oh, sorry, let me turn off the fan. Why I always forget to turn off the fan. Okay. Okay. So the limit as f of x as x approaches infinity of f of f of x equals L. Oh, that is brilliant. It makes life easier. And so I just learned an easy way of writing subscripts. But I still don't know how to do this without. Okay. X approach, and then x approaches infinity. Okay, huh. Can't just type it in. Interesting. Oh, it's without the I. F of x is going to equal sum L2. Okay. We denote, we say, so this is limits as infinity. It's possible that as x approaches infinity, f of x is going to approach infinity. This is denoted the limits at infinity. Okay. So the first statement that we read up here actually reads. Here, I'll go back out a little bit so we just get more of the page. Okay. So we're getting the limit of f of x as x approaches negative infinity. Negative infinity is going to be, don't know why it always shades all of it, is going to be L short 1. Okay, so from the left side, we're saying as the limit as f of x as n approaches doesn't make sense. I was like, as x negative infinity, as x approaches negative infinity is equal 1. And then the second statement, which is going to be easier to read, is the limit of f of x as x approaches negative, as x approaches infinity is going to be L2. Okay? Oh, more than one person joined. So we're talking about limits as x approaches infinity. So limits at infinity. Basically, this is our horizontal asymptotes. Okay. So what we used to do for horizontal asymptotes, we're still doing today. For those who just joined. Okay. So discussion of horizontal asymptotes. Now, if you remember horizontal asymptotes, an example, f of x equals 1 over x. And basically what I asked was, can f of x ever equal 1? I mean, can ever equal, oh yeah, hold on. Let's just expand this a little bit. There we go. Is that wide enough? Okay, so can f of x equal 0? This was my question. The answer is basically no, but it approaches 0 as x, as x approaches infinity, or negative infinity, or infinity. Okay? So, basically, a horizontal asymptote is kind of this approach. And if you can kind of recall, it's, I can't do it exactly. I was like, if I had maybe more time, I would probably download something to grab stuff on Microsoft Word, but you know, we don't have that much time. So, do you guys prefer the test on Tuesday or Wednesday next week? Just looking at the test schedule. I can do Tuesday. No, I can do Monday. There's projects due on Tuesday. Also can do Thursday. Maybe Thursday. If you guys vote in the comments, do your test. Oh, what day do you want your test? Sorry. Pre-cal project. What project would you have? Huh? What pre-cal project would we have? I don't know. Okay. Okay, here is a more this is a helpful definition. Okay, if we have some r, okay, if r is a positive, oh no, that's a bio project. Okay, if r is a positive real number, okay, yeah, okay, if r is a positive real number, then the limit, not the log, limit. Okay, the limit as x approaches infinity. That was bio and anatomy. So it says anatomy has an assessment on Tuesday, and bio has a project Tuesday next week. It wasn't pre-cal. Why wouldn't give you guys a project? Sounds too hard. Okay, if we have 1 divided by x to the r, this will equal 0. That will be our limit, okay? Furthermore, if x to the r is defined when x is less than 0, then we're going to have another limit that's pretty simple to say, and that is the limit from the left side, so the negatives. Sorry. Negative. Yeah, so vote what day you want pre-cal test. So x to the r, so 1 over x to the r, this will also equal 0. So if it's defined, what defined means is that we can actually plug in x values when x is less than negative. So if this function, right here, this function, sorry, if that function is defined in the negatives, then this limit exists. If it's defined in the positives, this limit exists. So this is going to be crucial for our next few problems, okay? There we go. Okay, so we're going to go over example 1 and 2, and number 9 and 19, okay? Okay, so example number 1 gives us this limit. Limit as x approaches infinity of 4 minus 3 over x squared. Okay, and I am going to show you how we would solve that problem. Okay? Take transition. Okay. So we have our limit as x approaches infinity of 4 minus 3 over x squared. Okay? Now, the first thing is we can actually break this into two limits, and it's very helpful to do so. The reason why I want to do this is because the limit as x approaches infinity of 4 is going to be pretty straightforward. And then we subtract the limit as x approaches infinity of 3 over x squared. Now, this 3 could go in front because it's multiplication, it's just a number again. So we have limit as x approaches infinity of minus 3, limit as x approaches infinity of 1 over x squared. Now if you notice, this is very similar to our 1 over x to the r. In fact, that is going to be the exact same concept. And the limit for this was that this gets 0, okay? Approaches 0. Okay, so what's the limit, what's the limit as x approaches infinity of 4? Well, that's just going to be our 4. And then minus 3, but what's the limit of this? Well, that's 0. So 4 minus 0 equals 4. So our limit, we would say the limit as x approaches infinity of 4 minus 3 over x squared equals 4. And not coincidentally, but that is our horizontal asymptote. Okay? If you're wondering, that is our horizontal asymptote. Here, let's load up a little bit. So I'm going to go through a few more and just through each example, okay? So if you have questions, feel free to ask them as I go through these. I'm not going to go through all the problems. I'm going to kind of skip, not around, but just skip a few. So I'm going to do f of x. So we're finding the limit of negative 2x plus 3 over 3x squared plus 1. So how we solve this, guys, is the first step is we need to divide everything by the highest power of x. Okay, so we would get the limit as x approaches infinity of negative 2x plus 3 over 3x squared plus 1. So what's our largest power? In this case is x squared, right there. So what we're going to do, apologies, I'm going to move over here. So we have our equal sign. So we get our limit as x approaches infinity. So we're going to have negative 2x divided by x squared plus 3 over x squared plus 3x squared over x squared plus 1 over x squared. Okay, so basically I divided everything by x squared, and then I'm going to simplify that. So we get the limit as x approaches infinity of, so the x's cancel, and you have an x on the bottom, so you get negative 2 over x plus 3 over x squared divided by, what's this become? This becomes 3 plus 1 over x squared. So, if we plug in infinity into this, if you divide by infinity, it's essentially 0. So, divide by infinity 0, divide by infinity 0, divide by infinity 0. So we get 0 plus 0 over 3 plus 0. Okay, sorry, they say minus 0, it doesn't matter. So we get 0 over 3. So our solution here, our limit is 0. And what's that tell you? Do we have a higher power in the bottom, in the denominator? Yeah, we started with a higher power in the denominator. Well, what about if we have the same power on top and bottom? Great question. I don't know who else is here besides Annie, but let's just assume it's Daniel. So Daniel, great question. Annie is obviously going to solve this for us. So g of x, so we're going to do g of x, and g of x is negative 2x squared plus 3 over 3x squared plus 1. So as Annie knows, we still divide everything by x squared. So Annie is just brilliant here. And she just goes, you know what? I'm going to divide everything by x squared because I'm allowed to. In mathematics, if you're allowed to, you do it. Just to test it out. It's kind of like experimenting in science. So, we're going to cancel out what cancels out. So as Annie knows, and she tells Daniel, she's like, look, see the x squareds cancel out here, and they cancel out here. Everything else stays the same. So we have negative 2 plus 3 over x squared over 3 plus 1 over x squared. Now, can we plug in this? Yeah, we can plug in the infinity. So you plug in infinity for x. This goes to 0, that goes to 0. So we get negative 2 plus 0 over 3 plus 0. What's our final answer, Daniel? Our final answer is negative 2, 3. Or maybe it's Fiona who's on. So Fiona is going to be the next one to take this next problem. So you see, if you looked at the coefficients at the top of the two greatest powers of x, you have x squared and x squared. So you would just take negative 2 and 3. And that would be our solution. But we need to test this out. Of course, we're going to test it out first by doing a problem that's nothing like it. So we have an h of x. And our h of x is equal to negative 2x cubed. Sorry. Negative 2x cubed plus 3 over 3x squared plus 1. So again, we're taking the limit as x approaches infinity. We're positive infinity right now. We're going to do negative infinity later. Okay. Plus 3 over 3x squared plus 1. What's the highest power of x? X to the third. Sorry. X to the third. So, what do we get? We're going to divide everything. We get limit as x approaches infinity of negative 2x cubed. Again, divided by x cubed. Plus 3 divided by x cubed. I don't know. I like that noise. Okay, 3x squared divided by x cubed. Plus 1 over x cubed. Okay, cancel that, which cancels, so we have an x in here, we have an x, no x here, and then this stays the same. So we get limit as x approaches infinity of negative 2 plus 3 over x cubed, 3 over x plus 1 over x cubed. If we divide by plugging in infinity in, we get negative 2 plus 0 over 0 plus 0, which equals negative 2 over 0. This is undefined, which means there's no limit. Okay, this is unbounded. Unbounded. Okay? So, you feel free to try the other two problems that I've given. So I'll write them here, and then you can try them out, okay? So our first question is going to be the limit as x approaches infinity of 3 over x squared plus 1, and then the limit as x approaches infinity of as t of 4t squared plus minus 2t plus 1 over negative 3t squared plus 2t plus 2. Okay? So feel free to do these two problems. I will give you a solid 30 seconds to examine them. You actually can do these pretty quickly once you get used to it, but at first it does take some mastery of how these limits plug in and stuff like that. So. Okay, so if you're doing the first one, and you look at the first one, you have 3 divided by x squared, which is going to end up tending towards 0, right? Because any number divided by infinity is going to end up in 0, and this 1 is going to stay the same. So it's going to end up 0 plus 1, which just equals 1. So straightforward. And this one, if you notice, we have two of the same powers on top and bottom. And so as we experience, you look at the coefficients. So the coefficients of these two, you have 4 on top and negative 3 on bottom, or negative 4 over 3. And that would be our limit. Now, if you're going, how do I know this? That is an excellent question. So let's go into how we know this, okay? How do we know this? Well, we're given an actual formula, kind of. So let's transition, and we're just going to go to our notes again. So if you're wondering, how did we get 4 over 3, negative 4 over 3, here we go. Okay, consider the rational function. It's blown up. Let's blow it up a little bit. Blow up, blow up, blow up, blow up. Okay, I think that's blown up enough. Okay, consider the rational function f of x equals to n of x divided by, let's just leave it d of x. Okay, you know what? Okay. Yeah, we'll just do it this way. Like, hey, okay. So f of x equals n of x, where, okay, this is going to be annoying, but I can do this. N of x equals a sub n, capital N, plural, and x to the n, okay, plus dot 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 plus a sub 0. Boom. We just delete some of these spaces, and then x is gonna, so numerator of x and denominator of x. Okay, d of x is gonna equal a sub m times x to the n plus plus a sub 0. What this means, that is why we have this a sub 0. It just means this is a polynomial. Okay, this is a polynomial. Okay, basically that's how the polynomials are going to be set up, where the limit of f of x as x approaches just positive or negative infinity, in infinite t, okay, is the following, okay, is as follows. Okay, the limit as x approaches positive or negative infinity of f of x is going to be 0 if the power of our denominator power of our numerator is less than the power of our denominator. So n is the power of our numerator, right here, and m is the power of our denominator. If the denominator has a greater power, then it will tend to 0. If the denominator and the numerator have the same power, if n equals m, sorry, let's line this up. Okay, I don't understand this. Don't ask me what's going on here. Okay, if n equals m, then let's just do this real quick. Okay, let's do C. Maybe there's an equation tool I can use. Brackets. Oh, that would have been nice. I don't know. Control Z. Let's just do this. Sorry, people. I am realizing I could have done this much easier. So let's cancel that. Just cancel that. Let's do brackets with stack. I always forget that I have this tool. Okay, Control V. Beautiful. Beautiful. Okay. So basically, if okay. So if the numerator has a smaller power than the denominator, it tends to 0. If the numerator equals the denominator in power, then you take the coefficients of the greatest power. If the numerator, n, is greater than m, the limit does not exist. Okay, that's a pattern. So, greater denominator, greater denominator tends to 0. Equal denominator and numerator, you look at coefficients. Numerator greater than denominator, the limit does not exist. Okay? We're almost done, people, with this section. Thankfully, this section is brief. Okay, limits of sequences. So, convergence. Convergence means that the sequence is getting closer and closer to 0. That's convergence. Okay. Not all convergence means it's a finite sequence. Never mind. Not going to talk about that. Okay. Let. No, not both. let f be a function of a real variable, okay, such that limit as x approaches infinity of f of x equals L. Okay? If, sorry about that, if we have some a sub n, if this is a sub n is a sequence such that f of n, sorry, equals a sub n. So basically, we're comparing function in a sequence. Okay, they're kind of the same thing. Okay. Yeah. Let's teach this to. Oh, it is a one. Okay. Okay. If an is a sequence such that f of n equals an for every positive integer, obviously n. We're just plugging in positive integer n, comma, then the limit of the sequence, as n approaches infinity of a sub n is going to equal L. So basically, you see that this function approaches, as x approaches infinity as L, such it's going to be the same way for a sequence if the sequence can be mapped to a function. Basically, if we have a function, we can figure this out. So these examples are going to give us, oh, look at that, functions. So examples 4, 5, 39, and 49 are going to give us functions. And we're going to use our brains on solving this. So we're going to finish. Wait. Oh, sorry, people. My computer froze. I can't actually do anything. Oh, great. What should I do? Well, let's just assume that it's still streaming. If it's not, then I'll just restart. Okay. I don't know what to do. Okay, hold on. Bear in mind, people, it's going to be a little bit weird for a second. Close program. We're going to open this one. And then we're going to open Google. Why am I doing it this way? Because it's easier. Let's just restore YouTube. I don't need the other things. Okay. Sorry, people. How do I go to my stream? Maybe it's still live streaming. The complicated thing of this computer dies. Okay, there we go. Sorry, people. It just died. Wow, interesting. Okay, thank you for your patience. Now, I'm going to show you how to solve these. Okay, life. Sometimes it is closer to a box of chocolates. Sometimes it's closer to. So we're going to check the limit as n approaches infinity of a of n. Now this is going to be, for our sake, we're going to do different problems. Let's start with 2n plus 1 over n plus 4. So in this problem right here, we see What are our powers of n? Our powers of n on top and bottom are the same. Top and bottom are the same, which means the limit is just going to be the coefficients. And the coefficients is 2 over 1, which equals 2. And that is going to be our limit. Okay? Let's try another one. Limit as n approaches infinity of 2n plus 1 over n squared plus 4. Okay, quick question. What's the power on top and bottom? Greatest power on top is 1, is n to the 1. The greatest power of n on the bottom is n to the 2. Which means denominator power is greater than the numerator. Which means we are going to tend towards 0. So greater denominator means we tend towards 0. Equal means we look at coefficient. And then we're going to look at, I think this is actually the end of our lesson. Okay, and then we're going to look at, okay, give you another problem. Limit as n approaches infinity of 2n squared plus 1 over 4n squared. What is the limit? What's the limit of this? Okay, what's the powers? Oh yeah, I'm gonna just send out a form for that. When would you like the test to be? Okay? Okay, so squared on top, squared on bottom is the same power. So then you look at the coefficients. Same power on top and bottom, look at coefficients. You have 2 over 4, which gives us 1/2. Lovely. There's our answer. Okay, do one last problem. Actually, we could do two. We'll do one last problem, and then you guys can ask me if you have questions. Okay, so the limit as n approaches infinity of 8 divided by n cubed times n plus 1 times 2n plus 1 over 6. Okay. So, in this question, we first have to kind of solve the top off and distribute. So we're going to do that. So first step is to distribute. So n times n plus 1 here. I'm just going to kind of do my math over here on the side. N times n plus 1 times 2n plus 1. That's going to equal n squared plus n times 2n plus 1. And then if I FOIL that, that's 2n cubed plus 3n squared plus n, and then that's it. Okay? So, that's the top. So what we get is we're going to get the limit as n approaches infinity of 8 times 2n cubed plus 3n squared plus n over 6n cubed. Can we cancel anything? Yeah, we can cancel these. So this is 4 over 3. So now we can distribute. So I'm going to distribute. So we get limit as n approaches infinity of 8n cubed plus 12n squared plus 4n over 3n cubed. Okay, question. What's the greatest power on the numerator and in the denominator? The greatest power. The greatest power on the top is 3. Greatest power on the bottom is also 3. So then we look at the coefficients of these two, and you do 8 over 3. That's your answer, okay? You don't have to show more work beyond that, okay? Very straightforward. Okay, students, that is the end of this lecture. We kept it under an hour, so really briefly, just want to let you know. I am up for doing the test anytime next week. Now, if you're curious, you're like, we haven't received our grade about chapter 10. I'm going to make sure that the grade doesn't really hurt you because it is a really weird time. And I don't want your grade to suffer because of how that test was graded late and anything like that. So basically, it's not going to be tremendously detrimental because otherwise, if like let's say you bomb chapter 10, then you would only have one other test to fix it besides the homework. And let's say the homework, I do need to put in corrections and grades for that. But then that's 50% of your grade, so of your semester grade. So if you bombed 2 tests, and the tests are worth half of your grade in quarter 4, and that's 50%, those 2 tests would be worth 25% of your total grade for the semester. That's craziness. We're not going to do that. I'm not going to destroy you that much. But I do want to make sure you know some key concepts. So what we're going to do is I'm going, this chapter, if I was to say something, I would be like, please study hard for this chapter. If someone doesn't do well on chapter 12, and they want to go to calculus, they're going to have to they're going to have to contact me about this chapter, okay? And did they get it, okay? Thank you guys so much. So I just made sure what day would work for you, so I'm going to give you guys a form. There's going to be more homework on this section, because I think this is pretty straightforward, honestly. You 10 problems should take you about, like, 10 problems of this, because you just look at the powers. It should take you a short time, okay? Thank you guys so much. Thank you, Andy, and whoever else joined who didn't write their stuff. You guys are great. Have a great day.